Okay, you guys, this geometry lesson is on angle, side, angle, and angle, angle, side. Let's go ahead and get started here. Angle, side, angle is if you have two angles and the included side of one triangle, and here's what this is talking about. Here's two angles and the included side, the side that's in between the two angles. That's what it means by the included side. So two angles and the included side of one triangle congruent to two angles and the included side of another triangle, then these triangles are congruent by angle, side, angle. Okay? All right, and then angle, angle, side is, oops, this should be angle, angle, side. I'm going to put that up there right here. So angle, angle, side is two angles and a non-included side. So let's just put that right here. Angle, angle, side. Okay, so two angles and a non-included side of one triangle congruent to, and this is the picture on this one, you guys. Um, Here's the picture right here. See how it's two angles and the non-included side? So I could have picked this side also. I just chose this one right here. But two angles and a non-included side. So this one or this one right here. If those two angles and a non-included side are congruent to two angles and a non-included side of another triangle, then those triangles are congruent by angle, angle, side. Okay? All right, and if I went backwards, side, angle, angle, that's the same thing as angle, angle, side right there. Okay, so those guys are congruent by angle, angle, side. Okay, so here's the 5 ways to prove triangles are congruent. Side, 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 angle, side, where the angle is included between the two sides, angle, side, angle, where the side is included between the two sides, angle, angle, side, where the side is a non-included side between the two angles, and then this is only for right triangles, the HL theorem. This is the hypotenuse and this is one of the legs. Okay? So are these triangles congruent? If so, explain. So are those triangles congruent? Yes, those are congruent by, if you put two dashes through right there, by the reflexive property, it would be angle, side, angle. So can you see that those, if I put that in there by the reflexive property, they share that side, so angle, side, angle. Okay, what about this one right there? Are those guys congruent? Look, side, angle, side, side, angle, side. Yes, by SAS, side, angle, side. Okay, what about this one? Are those congruent? Okay, this one goes angle, and then if I included this side right here, oops, let me get this right here. If I included this side right here, angle, side, angle, but this one doesn't go angle, side, angle. This side one goes angle, angle, side. So these ones, I can't say they're congruent because one is angle, side, angle, and uh, one is angle, angle, side. Okay, so those ones are not congruent right there. All right, what about these ones right there? That one's pretty easy. Those that when it's side, 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 to me it's really easy. So three sides equal to three sides. So yes, side, side, side. How about that one right there? Okay, if I put the markings in right there, would they be congruent? Let's see, it would go angle, angle, side, side. And what I tell my students is don't make an angle side side of yourself. And I spell it side side angle, but if you look at it backwards, angle side side ASS, I tell my students don't make an angle side side of yourself because you can't do that, you guys. Okay, only angle angle side does. All right, so what about these guys right here? Okay, angle angle side, angle angle side. So yes, angle angle side. That's okay. All right. Okay, so here are the picks that go along with the 5 ways to prove triangles congruent. Okay, here's side, side, side. Here's side, angle, side. Notice it's the included angle. Here's HL, only for right triangles. HL, the hypotenuse and leg. Here is angle, side, angle. Notice it's the included side. And then this one's angle, angle, side, where it's the non-included side. Okay? All right, so, whoops, and I think I'm done.